Next, question number 24. In alkaline medium, ClO2 will oxidize H2O2 into O2 and reduce itself into Cl minus. Therefore, how many moles of H2O2 will oxidize by 1 mole of the ClO2? ClO2 plus H2O2. They said that ClO2 is undergoing reduction into Cl minus. Next, they said that H2O2 has been converted into H2O and O2. So, in general, when H2O2 act as the electron supplier, that means reducing agent, 1 mole will always supplies 2 moles of electrons. Next, now identify the change in the oxidation state of the chlorine. Here, before reaction, the oxidation state of the chlorine is +4. Now, oxidation state is -1. That means the change is +4 to -1. So, what is the change? 5 units. 5 units. That means 1 mole of the ClO2 is gaining 5 moles of electrons, whereas 1 mole of H2O2 is supplying 2 moles of the electrons. 2 moles of the electrons. Now, in the question, we have to identify how many moles of H2O2 will oxidize 1 mole of the ClO2. How many moles of H2O2 will oxidize by 1 mole of the ClO2? By 1 mole of the ClO2. So, according to this reaction, first now we have to identify the how many moles of the H2O2 will be oxidized by 1 mole of the ClO2. So, for that purpose, first we balance the reaction with respect to exchange of electrons. So, for that purpose, the shortcut method is whenever after identifying the number of the total change in the oxidation state of the 2 species, exchange those values. This 5 you keep here, this 2 you keep here. Cl minus like this. The meaning of this exchange is now 2 moles of the ClO2 will react with the 5 moles of H2O2. That means 2 moles is reacting with 5 moles. 1 mole will react with how many? 5 by 2. That means 2.5 moles. Now, identify the option where 2.5 moles is shown. In the option 3, 2.5 moles is shown. Therefore, answer is 3. Next, question number 25. First, let me represent the reaction. Here, H2SO4 is reacting with the hydrogen iodide. The products as shown are H2S plus I2 plus water. Now, in this balanced equation, we have to identify the number of moles of hydrogen iodide participated, and the number of moles of iodine produced, and number of moles of water produced. That means we have to identify the value of the Z, Y and X. Again, for this purpose, identify the change in the oxidation state of the each species. Here see, H2SO4 has 1 mole of H2SO4 has 1 mole of the sulfur. That sulfur is in the +6 oxidation state. Here when it participates in the reaction, the sulfur has been reduced to the -2. Therefore, 1 mole of H2SO4 is gaining how many electrons? 8 moles of electrons. Next, these 8 moles of electrons are being supplied by the hydrogen iodide. You see the oxidation state of the iodine here, -1. Here oxidation state is 0. That means here each iodide ion is supplying 1 electron. 1 mole of H2SO4 requires 8 moles of the electrons. Therefore, you take 8 moles of the Hi. 8 moles of Hi. Now, 8 moles of Hi will supply 8 electrons. Then those 8 electrons will be gained by the H2SO4. Here we will get the H2S. Next, here we have taken 8 moles of HI. Therefore, total iodine atoms must be 8 here. Therefore, put 4 here. then H2O. So with respect to exchange of electrons, now we have balanced. Now count the oxygen atoms both sides. Here 4 oxygen atoms, here 1 oxygen atoms. Therefore here still how many oxygen atoms are deficient? 3. Therefore make it total 4. 4 oxygen atoms, 4 oxygen atoms. Next balance the hydrogen atoms. Here you count the hydrogen atoms. 8 hydrogens plus 2, 10. Here 2 plus 8, 10. So hydrogens are already balanced. Therefore here x is equal to 8. Next here y is equal to 4. Next z is equal to 4. So therefore identify the option where 8, 4, 4 are shown. Answer is 3. So total time ఎంత వచ్చిందండి? 50. మళ్ళీ రాస్తాం. Next. So here they have taken MnO4 2 minus. Now this MnO4 2 minus, oh yes. Next question number 26. Here MnO4 2 minus, that is a potassium manganate, it is undergoing disproportionation. So MnO4 2 minus, it is undergoing disproportionation into MnO4 potassium permanganate plus Mn2O7. Mn2O7. This is the disproportionation reaction given. Here we have to identify the number of moles of MnO4 minus it is participating in the reaction. So first, whenever if disproportionation reaction is given, first you balance the atoms which are undergoing disproportionation. In this reaction, see, if just by observing the oxidation state of the oxygen here minus 2, minus 2, minus 2. Therefore, there is no change in the oxidation state of the oxygen. Next, only for manganese, there is change in the oxidation state. So, since the oxidation state of the manganese is changing, here identify the oxidation state. Here plus 7, sorry, here oxidation state is plus 6, here plus 7, here wait 1 second, plus 6 plus 7 MnO4 again from the beginning. Next question number 26. In this problem they have given the MnO4 minus, this MnO4 2 minus, it is undergoing disproportionation. So when it undergoes disproportionation, the products were shown as MnO2 and Mn2O7. Here the oxidation state of the manganese is plus 6. Here oxidation state is plus 4. Here oxidation state is plus 7. In this disproportionation reaction, 1 mole of MnO4 2 minus produces how many moles of MnO2 and how many moles of Mn2O7. That aspect we have to find out. For that purpose, first you balance the atoms which are participating in the disproportionation. Here you see 2 manganese atoms plus 1. Total 3 were there, but here only 1 is shown. Therefore, first you balance the manganese atoms which are undergoing disproportionation. That means 3 moles of the MnO4 2 minus is participating. I am showing those 3 moles separately. Here oxidation state is plus 6, plus 6, plus 6. Here one manganese is coming here. The oxidation state of this manganese is +4. Another manganese is coming here. The oxidation state is +7. Here another manganese is coming here. Oxidation state is +7 here. That means when this manganese undergoes oxidation state change from +6 to +4, that means it is gaining how many electrons? 2 electrons. Gain of 2 electrons is taking place in here. Here +6 to +7 means it is releasing 1 electron. +6 to +7 means it is releasing 1 electron. Here 2 electrons are being released. These 2 electrons are being absorbed into the another manganese atom like this. Therefore, totally here 2 moles of electrons are being exchanged. 2 moles. 2 moles are being exchanged, but how many moles of MnO4 2- is participating? 3 moles. 3 moles is participating, 2 moles of electrons are exchanged. For 3 moles of MnO4 2-, it will produce 1 mole of MnO2 and 1 mole of Mn2O7. Therefore, for 3 moles, it is producing 1 mole of MnO2. For 1 mole, how many moles will be produced? 1/3 mole of MnO2. Similarly, 1/3 mole of Mn2O7. So, moles of MnO2 1/3, moles of Mn2O7 is also 1/3. 1/3 and 1/3. So, select the option where 1/3 moles of Mn2O7 and 1/3 moles of MnO2 are participating. So, 3. Next, question number 27. Here sucrose C12H22O11 is converting into CO2 and H2O. In this reaction, what is the change in the oxidation state of the carbon? Here oxidation state of the carbon is 0, here +4. That means every carbon it is undergoing oxidation. Therefore, whenever if the sucrose converts into CO2, that is an example for oxidation. Hence, option 1 is correct. Next, question number 28. In which of the following reactions H2O2 is acting as the reducing agent? So, first observe each reaction. In the first reaction, they have shown that FeCl2 is reacting with the HCl and H2O2. Here FeCl3 is being formed plus H2O. H2O. Now, in this option, first identify the change in the oxidation state of each species. Here iron is in +2 oxidation state. Here iron is undergoing oxidation state is +3. That means iron here it has undergone oxidation. Since it has undergone oxidation means this hydrogen peroxide might have absorbed these electrons. Therefore, because of hydrogen peroxide, FeCl2 has undergone oxidation. Therefore, H2O2, we can say H2O2 is acting as the oxidizing agent. Here H2O2 is acting as oxidizing agent. But in the question, we have to identify the reaction in which H2O2 acts as the reducing agent. In the second option, they have shown the Cl2 plus H2O2. Here HCl plus O2 plus O2 is shown. Now, here oxidation state of the chlorine is 0, here oxidation state of the chlorine is -1. That means chlorine is undergoing reduction. Why it is undergoing reduction? Because of reaction with H2O2. Therefore, we can say H2O2 is acting as the reducing agent. Reducing agent. Next, in the third reaction, hydrogen iodide plus H2O2. Here H2O plus I2. In this reaction, the oxidation state of the iodine here -1, here 0. That means hydrogen peroxide, because of this reaction with H2O2, the iodide is undergoing oxidation. Therefore, H2O2 is acting as the oxidizing agent. Next, in the fourth option, H2SO4 plus H2O2 gives H2SO4 plus H2. So, in this reaction, H2SO3, H2SO4. In this reaction, sulfur is in +4 oxidation state, here +6 oxidation state. That means because of the reaction with H2O2, this H2SO3 is acting as is undergoing oxidation. Hence, it is acting as the oxidizing agent. So, in the first option, third option, fourth option, hydrogen peroxide is acting as the oxidizing agent. Only in the second option, it is acting as the reducing agent. Hence, answer is 2. Next, question number 29. Oxidation number of the phosphorus in Mg2P2O7. Represent the formula of the Mg2P2O7. Here in Mg2P2O7, see 2 manganese atoms, 2 phosphorus atoms plus 7 oxygen atoms. Here 2 plus 4, 2, 4 plus 2, 6. Here the remaining 2 phosphorus atoms, they will exist like this. Yes, wait. Just ఇదేం రాదు కదా, ఇది రాదు. Next, question number 29. Question number 29. The oxidation number of the phosphorus in Mg2P2O7. First, represent the structure of the Mg2P2O7. So, in this Mg2P2O7, this is the structure of Mg2P2O7. Here this phosphorus, here it has lost 2 electrons, here it lost 1 electron, here 1 loss, here 1 loss. That means here 3 loss, here 2 loss. Total loss is plus 5 electrons. Therefore, oxidation state of the phosphorus is +5. Here +5. So, select the option where +5 is shown. Answer 3. Sorry. Question number 29. Next, question number 30. Among the following, identify the species with an atom having +6 oxidation state. In the first option, they have shown MnO4 minus. Here, identify the oxidation state of the manganese. Manganese oxidation state X. Here, plus minus 8 is equal to minus 1. Therefore, X is equal to +7. So we have to identify the option in which oxidation state of the central atom is +6, but here we got +7. Next, second option. In the second option, they have shown CrCN 6 times, 2 minus. Here, let us say the oxidation state of the chromium is +6, X. For each cyanide -1, therefore 6 such ions are there, -6 is equal to -2. Therefore, X is equal to -2 + 6. Therefore, answer is +4. But here we have to identify the option in which oxidation state of the central atom must be +6. But here we got +4. Therefore, it is also wrong. Next, third option. In the third option, they have shown NiF6 2 minus. Here let us see the oxidation state of the nickel is +6 X. For each fluorine -1, so 6 are there, so -6 is equal to -2. X is equal to -2 + 6, so +4. So here again we got the +4. Next 4. Here CrO2 Cl2. Here chromium X. For each oxygen -2, therefore -4. Next for each chlorine, so -1, so 2 are there, so 0. Therefore X is equal to +6. Therefore in the fourth option we got the central atom with oxidation state +6. Hence answer is fourth option. Represent the answer 4. Okay, sir. ఎంత టైం వచ్చిందండి? 1 hour వచ్చింది. నెక్స్ట్ థర్మోడైనమిక్స్. చేస్తాం, మీ ఇష్టం. చేస్తామంటే చదవం, లేదంటే రేపా మీరు ప్లానింగ్. అది మీరు ఖాళీ దొరుకుతా? అదే ఇప్పుడు చేసేద్దామంటారా? 7:30 అంటే అది కూడా 1 hour పైన పడుతుంది. పెద్ద ప్రాబ్లమ్స్ వస్తాయి అందులో. మండేనా? మండే మార్నింగ్ రమ్మంటే మార్నింగ్ వస్తాను నేను. మళ్ళీ మండే నైట్ ఊరు వెళ్ళిపోతున్నా. మళ్ళీ 1 week రాను. మండే మార్నింగ్ 1 hour రమ్మంటే వచ్చేస్తే మండే మార్నింగ్ 9-10 కానీ. ఓకే, మార్నింగ్ 10కి వస్తాను నేను. మళ్ళీ ఎందుకంటే మళ్ళీ నేను మళ్ళీ 1 week దొరకను, అట్లా 10 days దాకా దొరకను. మండే మార్నింగ్ షార్ప్ నేను 10కి వస్తాను, కంప్లీట్ చేసేసుకున్నాను. ఎందుకంటే ఎమర్జెన్సీ ఏం లేదు కదా అట్లా.